Hi, and welcome to this project for the course of Perception in ROS in Robot Ignite Academy. So congratulations, you now know the basics of perception in ROS. And what I want you to do now is do this project so that you really learn all these skills, because one thing is doing it with me and with some tips and exercises and so on, but now you'll be alone. You'll have to apply all the things that you think you know to a project in a new robot, in a new environment, new objects and new persons. So what's this simulation about? So as you can see, you have an environment very similar to the one in the follow the line, but the color is different. You have different colored styles, some are the same color, and different sizes. Then you have a different robot. This robot is it's a model of the Aibo ERS7 of Sony, generated by, let me read because I wanted to say it right, Toshitada Doi, from the Digital Creatures Lab of Sony. They made fantastic robots, very ahead of their time, in 1999. So you have to be conscious that they made perception, they made all the perception that you're going to do in this exercise and more in 1999. So it's a fantastic robot. So you're going to use a simplified version in some aspects and an improved version in others. So the simplified is obviously the movement. You're not going to move the Aibo robot through walking. This would be for a totally different topic, which is locomotion. If you're interested in a course like that, please leave a thumbs up and leave it in the comments telling us, because we would be delighted to know if you're interested in locomotion courses. But in this case, you're going to move it in the same exact way as you moved the Kabuki robot, as you moved any of the robots that we used, except the Amira, which didn't move. Okay, and you will move it publishing in this topic, the Aibo ERS7 command-ville. You have also some, let me go here, have it prepared. There we go. So I have here an Aibo move with keyboard that you can use, of course. It's installed in the system. And what it allows you to do is move the robot around, turn it, and quite it. So it moves exactly the same way as the other robots. Furthermore, all the controllers are working. All the controllers. So the ears, the tail, the legs, the head, the neck, anything, it's moving. So for example, just that you're not walking with that, but you can generate gaits that simulate that it's walking when you walk. It would be amazing that you did that. Here is a tiny example of that. You can move the legs as you wish. The controllers are already done and made, so don't worry about that. And you can put it in any position that you want. Here you have other examples, so you can move the head and move the tail. What you will need in this project to do it, the basic exercises, will be moving the head, because you need to point the camera to the places that you want, and also the tail just for telling you that he's detecting, for example, a face, or he detected a person, Olive or Timmy. Now that we're talking about them, you have two persons in the environment, two kids. One, it's Timmy, he is moving around in circles here in this area. and you will need it for the exercise of people tracking and the other face detection, face recognition. And then you have Olive, which is, it's the girl here that she's static, and you use it for more face recognition and face detection, but basically face recognition. And then you have also the classical pink ball of Aibo, which is a pink sphere, nothing special about that, which you will use for, you guessed it, blob tracking. And here you have a toy that was given with the robot, with Aibo, which is a more complex shape, and you will use it for object recognition. Perfect. And then, of course, we talked about this, the map. So, yeah, much better. So here you have the map, which is more or less the same as the following line, but it has a different lines, different stars, and the color is different, so you can't recycle exactly the code for the following. Okay, here you have the green star, which is the one that you will use as simulated charging station, wireless charging station, and that's quite it. The only thing that I have to talk about is the camera. So this robot had some sensors like contact sensors on the feet, which you don't need here, some contact sensors in the back and the head, and it had an RGB normal CMOS camera. In this case, we've upgraded it to technology of 2017, and it's a depth camera. So you have RGB camera, but you also have depth information. And I think that's quite it. So here you have the robots. One thing is, what's this effect? So we're going to see it right now. I'm going to show you, but here you have a photograph of some of the problems that you have with depth sensors. So this depth sensor has a minimum range, which if it's closer to the object, you won't be able to detect anything. So you'll have to use the RGB camera for that. Okay, bear that in mind. So let's have a look to the different topics. For example, we'll use the RViz because I think it's practical. Okay, okay, there we go. So now I'm going to get rid of the point cloud for the moment. So we have the TFs. As you can see, it's loaded with TFs. Let's get rid of them for the moment. We don't need them. So here you have the Aibo robot in all its glory. So you can see that you're moving this platform here when you move around. So let's add, for example, some camera info. The camera info element it's useful because it gives you information of where the camera is pointing. See. Sorry. Okay. Let me just. Okay. Okay. Now, what I just did is something it's normal that you need this to do, is the fact that some cameras and especially, well, some sensors and especially cameras sometimes need to be asked the information before they start publishing. So this is the way of doing it. If, for some reason, sometimes it happens with RVS. So you have it here. Then let's add, for example, a camera. Let's add a camera. There we go. Okay, there we go. It's superimposing this information, so I'm going to get rid of it. But before, you see that here is where the camera is pointing to. Okay, so bear that in mind. It's really useful for that. Let's get rid of this. So in this case, we're seeing the depth information. Let's see if we can do it a bit bigger. There we go. So you can see olive there and then the floor. Well, okay, if for example we change the topic and we select the RGB, there we go. As you can see, it's a bit slow to get the flow of the information, but when you get it, you have it there. Fantastic. Then we can put the point cloud. Let's put the point cloud. So as you can see, sometimes, especially in very big simulations and so on, depending on your computer, but it could happen this. Okay, I'm showing you this exactly for this reason, because maybe you start and you say, okay, this is not working. Don't worry. It's just that the flow of information sometimes needs to, you have to ask it first and then it starts, or sometimes you have to reselect the topic so that it starts publishing. So you reselect it, you press enter, and be a bit patient and you'll have the information. So here you have, as you can see, which is quite nice. There we go. So here you are seeing that it's getting a bit of the line and also the ball here. Let's zoom out. I don't think he's getting, oh yeah, he's getting her. As you can see, the depth sensor has a lot of range. Okay. Here has more definition and here less, but you're getting some information of the person here. So great about that. And that's more or less it. As you can see here, it has the minimum that I show you. So bear that in mind. All these little tiny things of the sensors, especially the thing of starting to publish. So don't panic. Okay. Oh, we can save it. Yeah, why not? Okay. So I've talked about this. Then we've seen this more or less. We have the depth images, we have the RGB images, and we have the point cloud, which is three-dimensional data, while the depth is just a two-dimensional data image that gives you some idea of the depth. And then you can put the depth as, so the point clouds as point cloud 2 element, and you'll see the colors and so on, or a depth cloud, which is just pure distance information. That's it, no color. And this finally, it's something that it's a nightmare when you start with perception, is the fact that a lot of sensors, especially cameras, flip their image or flip their frames. As you can see here, you have the camera frame. Okay, the camera is oriented in this way, but the optical frame is oriented the other way. This can be a nightmare if you try to process information from this camera and you see that it's the other way around, and very strange things happen. So bear that in mind, and I explain this because you'll find it everywhere. In every robot that you work with, it's very probable that you find this, that the frame of the camera is not the same as the optical frame, which is the sensor frame, let's say, as you process the data. So be careful with that. The elements, we talked about that. And now the exercises. So we've talked about it in each unit. I'm going to go over them. So we have Unit 1, the vision basics. So you have to make the Aibo robot look for the pink ball. That's it. And when here I give you some tips or some things that you should try to do. To when you are within less than 0.2 meters, you have to make Aibo go into a pointing pose. So move the head and a leg, for example. That could be funny. And oh yeah, and this could be an extra. So this is just that you are able to detect the ball and read the distance and do an action. This one is that you have the three-dimensional position and you can do through TFs make the paw point to the ball. That would be amazing. Or the head. And do the tracking. That would be amazing. Okay? Fantastic. Unit 2, following a line. Well, that's quite self-explanatory. So you have to follow the line, the white line, that you have painted here on the floor. And then you have to go reach the green star. When you reach the green star, you have to move the legs so that in real life it would go to the floor, like sit and so on. And that way it would wirelessly charge. Okay, so it's a following exercise. Then there are some extras. For example, do an action that you say, okay, go to the red star, go to the green star, to the blue one, to the black one. Okay? Then, Unit 3, flat surface and object recognition exercise. The original Aibo, when he detected the... it's because I'm finding it now. Oh, there we go. So the original Aibo, when he found the bone in this fashion, what he did was position itself here and pee, or simulate that he peed on the bone. So the exercise is just that. You have to emulate this action that the original Aibo did by detecting the object, the three-dimensional object. So you have to search for it. Maybe you need some blob tracking, some color tracking, and so on. And then when you have it, you have to position yourself and then do the gesture. Okay? And as extra, just detect the surface, the ground, and know at what distance you have the ground. That could be something interesting. Okay? Then, Unit 4, people perception exercise. So, you have to make the Aibo robot search for human faces. Then, get to their position. And when the Aibo is close enough, around 1 meter, wiggle its tail and then go to another person. You can do it as complicated as you want. You can do face tracking, that if it moves, this is what I say here more or less, that if he moves near a person, it starts to track the face with its own head. So the head moves, tracking the face. That would be great. As you wish. So the basic is face detection, go to the person and wiggle the tail. That's the basics. If you want to do it more complex, fantastic. Okay, so Unit 5 would be face recognition exercise. So you have to look for Olive. You have to look for your owner. So what you will have to do is look for first faces, persons, and then get closer, because the face recognition won't work at this distance, for example. So you have to get close enough to know which person is it, and then recognize and say, hey, it's Timmy, so he's not there. Then memorize more or less the position and say, okay, if I detect a face here, then it must be Timmy. So that's not it. And I'll detect another face here and I say, okay, maybe it's that one. I go closer, get closer and say, hey, it's Olive. Yeah, fantastic. That's the exercise. The same thing. You can do it as complex as you want. And finally, the unit 6, which is people tracking exercise, you have to track Timmy. You have to track this boy and try to move around and follow him. So the first thing you have to do is do a searching for Timmy algorithm, and when you find him, more or less, then you have to start people tracking. Okay, fantastic. And here you have extra exercise. So create an action server that when called, you can ask him to do any of the tasks that you made in these exercises. And here we give you some hint on how to do this action, which is string action to perform. Then the result is the result of the action, and the action feedback, which would be strings also. So it's all the time strings. And then another one would be create a launch file that launches our viz with a custom configuration. I think I highly recommend you that you do that at the start. And congratulations, you finished the perception project when you finish all this. So we would be delighted to know all the things that you do. So you can post it in the comments below, or send a tweet something, a video or something. We would be very happy to see what you come up with. You can also spawn new objects as you did in the object recognition as you wish. So the sky is the limit. So this is the end of this project unit. And then you ask yourself, okay, what do I do next? So when you finish the project and all that, what you can do? Well, you can go to ROS Development Studio and continue your development there. Practice all that you've learned in this course or in other courses. Use simulations that we have there, or build your own simulations. Maybe build your own courses. I don't know. Then you thought that maybe there was some stuff here in this course that you didn't understand, or maybe you want to learn more. Go to Robotic Night again and search for the new courses. We publish new courses periodically. So, and if you leave in the comments some projects that you're interested in, we would be delighted to hear about that. So for example, you want to do I would like to do a locomotion course, then leave it in the comments. Or I would like to do, a ballistics robot, anything that you think or you need, put it in the comments below. And thank you for all in behalf of all the Construct team. We hope that you learned a lot in this course. Leave a like, it helps a lot, and subscribe if you haven't still, and hope to see you in another course. So, bye.